In the workshop, this is a special feature all about a Ctx 3030 metal detector. I have one of these. I bought it recently from a friend and it's absolutely amazing. The only problem with it is the coil mounting is broken, and this apparently is quite common. The mounting lugs are very thin. Have a look. The plastic housing for the coil is made from ABS. This is a special kind of plastic. ABS is quite a strong material, but I would have preferred it, I think, if the coil housing had been made from polypropylene. And also, not wishing to be critical, but I think these lugs are a bit on the thin side. The first thing to do is to unrepair it from the previous owner's attempts. The lugs had previously been repaired just by putting 5-minute epoxy resin all over them, and the epoxy resin didn't stick the ABS back together, so I scraped it all off with a scalpel. So what's all this got to do with steam engines? Well, the answer to that is nothing at all. But some of the principles that I'm going to show apply to repairing parts of steam engines. Although steam engine castings are generally not made from ABS, the principles of repair are very similar. The first thing to do after removing all of the epoxy resin is to use a coarse piece of sandpaper to score the parts, so when I glue them back together there will be a very good key for the adhesive. To get into the corners I'm using a piece of wood with some sandpaper on it. I noticed in this clip that I haven't got all of the epoxy resin off yet, so there'll be more about that in a moment. When I bought this metal detector, I knew about the broken lugs because the seller is a good friend of mine. The first thing I did when I bought this detector was to look on YouTube for a solution, and I think I typed in something like how to repair the lugs on a Minelab Ctx 3030 coil. Changing the subject momentarily, this is very satisfying. Scraping off this 5-minute epoxy resin with a scalpel shows just how weak it is. The adhesion to the ABS is very poor. When I turn the coil over, you can see the construction. The main coil wiring is encapsulated in the housing, and that's done with some resin that's well stuck to the ABS. The part of the coil assembly that I've just been pointing at with this paintbrush would be ideal if I drilled 2 holes in the voids and bolted a machined nylon assembly to the top using plastic car number plate bolts. But first I'm going to see how I go on. I'm going to do it this way. This is a piece of gasket material and I'm making a pattern. Why did I use gasket material? Well, no reason. I could have used cardboard, but this is very close to hand on the workbench. In my videos, quite a lot of the time I mention something called the calibrated eye, and this is from years of practice. You learn to sort of see things in space. And by that I do not mean unidentified flying objects or planets. I can look at a shape and I can make a template to fit around the shape, although this one is a bit too tight. And it's slightly difficult because the edges of the moulding are rounded, so I kept trimming it until I got a fit I was happy with, like you see here. I use the cardboard template a lot when I build steam engines, particularly good for making a boiler wrapper. Draw the positions on the cardboard where the holes are for the safety valves and things like that, and then cut it out of the metal, and it's generally okay. You can use the same principle for cylinder cladding also. In this case I'm holding the broken part in position and drawing round that as well, and eventually I arrive at this. In this clip, using the scalpel that's on the bench, I cut the hole in the centre, but it wasn't big enough, so now I'm going to use a bit of science. This started out life as a parallel grinder, but I trimmed it on my grinding wheel in the outer part of the workshop until it was tapered, and you've just seen what it does, straight through the pattern, and it leaves a really nice round hole in the centre of the template. In this clip, once again using the scalpel, I'm cutting the shape from the gasket material, but it's a bit rough. As you can see, the way the scalpel cuts going around corners isn't very smooth. Once I cut out the template, I got it to the correct smoothness and size by using a piece of coarse emery cloth. And it ends up looking like this. The good news is I only need to make one template because both sides are identical. This is not a piece of carbon fibre, it's a piece of fake ABS carbon fibre which I bought off eBay. And on the non-carbon fibre effect side, I marked out the shape using the gasket template. The first thing to do is to drill the hole in the piece of plastic, making sure that it is 100% in the correct place, which is in the centre of the marked ring. During the drilling process, quite a lot of the ABS plastic stuck to the drill, and I'm saving the drilling swath for part 2. I have a use for it which I will show in the second episode. It's bandsaw time, and this ABS is horrible stuff to cut because the bandsaw blade melts it and it sticks underneath the blade. so I have to back off the plastic from the blade frequently. Once the melted plastic hardens, it snaps off. At this stage I'm not too worried about getting a perfect finish, because the part is slightly bigger than it needs to be. Cutting out this area is a bit fiddly because the blade is too wide to go around the sharp corner. So I take many plunge cuts to weaken the plastic, and you'll see what happens in a moment. Usual health and safety warning: do not cut your fingers off in the bandsaw because it will be very difficult to pick up the part. Over now once again to the rotary grinder. This, by the way, is held in a special adapter that's available from Proxxon to hold Proxxon motor tools. It screws to the bench and holds the tool steady. In this clip you can see that the fake carbon fibre effect is just a sticker, and I'm going to remove all of this very shortly using my belt sander. It's not a good idea to rely entirely on machine tools for jobs. In this clip I'm finishing off the job using some sandpaper. But it's a bit springy and doesn't fit very well, so I need to go back to the grinder and very carefully grind the rear part at an angle like this. And that will allow the mounting lug to be bonded really tightly to what's left of the original. The gaps around the bottom will be filled in the next episode. In this clip I'm just checking that both of the parts are identical and they align perfectly. And here they are, the mounting lugs are completed. So now it's time to just mock up the thing using a bolt to make sure everything does fit properly and the bolt's at the right angle. In this clip the camera angle distorts the perspective because the new lugs are exactly the same size as the old ones. All I need now is the special adhesive that I've ordered that I think is going to arrive on Friday, and I can continue the job and finish it off. This is going to be much better than some of the other repair attempts I saw on YouTube when I first got the detector, and it's a lot cheaper than buying a new coil. In the meantime though, I did buy this coil. This is the larger one, and here's the detector in my studio resting against my Hammond organ. It's a thing of great beauty, and the metal detector's not bad either. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists, and by doing that you will find it very easy to find other videos that you may like to watch.